Hello, everybody. Finley Ledbetter here from Group CBS's High Power Lab. We're in Farmers Branch, Texas, basically in the place where we do most of our acceptance testing and high voltage, high power verification for projects that we work on at Group CBS. Today, we're going to talk about MTS or maintenance standards. In the past, we've talked about life cycle of switchgear. We've talked about acceptance testing, and that kind of segues into maintenance testing. And then if you didn't see segment 1 or 2, if you'll send us a text email here, or if you'll chat us up, we'll get you a link to those videos so you can catch up with modules 1 and 2. We're planning on about 10 modules to run through everything that Group CBS does. And in a couple of months, we'll have the next section. So this one's entitled Group CBS Module 3, the Full Monty. And we're going to talk about a very quick overview about Module 1 and Module 2, but not go into any detail. And then we'll move on to maintenance testing. If we're going to go back and review what we've talked about in the first 2 segments, and what we're doing here is, the day that you get your equipment, actually the day it's built, the day it's specified, it starts to age. And it ages as far as obsolescence goes. It ages as far as operating conditions go. It ages as far as where it is in its life cycle. Time, the environment, if it's repetitive duty application, a lot of equipment's not designed for repetitive duty, yet it gets put into those applications and causes a lot of problems. The environment, is it sea level? Is it in the mountains? Is it cold? Is it hot? Are you varying the load? Is it close to salt water? Is it in a humid environment? All these things come into play. What type of airborne contaminants are you dealing with? Carbon black plant, a titanium pigment plant, a steel mill, a cement plant, places that have a lot of airborne contaminants, everybody knows that's also a problem. And that contributes to reducing the useful life or the life cycle and increasing the required maintenance interval, which we're going to talk about here. So there's various factors that affect overall safety and reliability. Environment, what type of equipment did you buy? Is it applied correctly? Is it misapplied? Where are you at? And how often and how are you using it? Knowing when to test, knowing when not to test is critical. So we're going to talk a little bit about testing intervals, maintenance intervals, not just testing. Maintenance is not just testing. Maintenance is putting your eyes on it. It's cleaning, it's listening to it, it's smelling the room. Everything tied into one has to do with a critical good maintenance program. You walk into a climate controlled pressurized substation room and you smell something different, you hear something different, any of those sorts of things need to be investigated. And the operators, the electricians that are in these situations, or the technicians that are contractors, need to be aware, and they need to pay attention to these critical telltale signs. It's always not smoke bellowing out of the switchgear or out of the panel. Quite often it just changed tone, it changed frequency, something got loose, the sound changed, temperature went up a few degrees. Sometimes it's a smell. You can smell when older organic insulation starts to get hot. It's a definite smell to it. When it starts to release some of the material and release a smell when the varnishes start to cook, you'll smell it. So with proper maintenance timing of equipment, our people will suffer. What that means is if you don't do proper timing, if you try to extend the maintenance too long, you tend to operate the equipment at too high a capacity by not changing your maintenance interval. So quite often equipment's installed, it's installed at say 50, 60, 70% of capacity. Over its life cycle, that capacity has changed. People add a furnace, add a building, add a heater, add a bunch of pumps, add air conditioning, add more people, whatever they do, and the load capacity goes up. So eventually the load on the equipment goes up, the operating temperature goes up. So over time, possibly the maintenance needs to change. What used to work when it was 50% at capacity, now it's at 90%. If it's a critical circuit, you've got to consider changing and not sticking with the old way of doing maintenance as far as the timing goes, or even the tests and the cleaning and the inspections that you're doing may need to change as the equipment ages and as your loads increase. Okay, let's see if we can change the next slide. So the big picture is, equipment is basically, and this is a review of module 1, basically the equipment is designed to operate about 20 years. At that point, the manufacturer, sales team, and marketing team built in some planned obsolescence to get it away from you because they want to sell you new equipment, okay? That can't really happen because the cables, the operating conditions as far as what gets built around the switchgear won't allow you to get it out. So there's all kinds of operating conditions that go into this site-specific, maintenance-specific equipment, operation-specific, to where you can't necessarily go in and easily change it out. There's no real estate to put a new substation. You can't remove the cables and bend the cables. There's a new steam pipe. There's a new wall. There's a new building. You can't get to it. So you're going to have to make this equipment stay in place and live a long time. And there's nothing really being developed today to replace the equipment that you have today. So if you look at this timeline here, the original equipment was manufactured, let's say in the 80s, okay? The majority of the infrastructure in the US is late 70s, early 80s. Obviously, some of you have equipment that's put in the 2000s, 210, 215, 220, but the majority of the equipment was put in the 80s. That's when the older air gear and the older oil gear was systematically primarily replaced with vacuum. Now, today, there's still more air gear, air breaker in service than vacuum, but eventually all the air gear will be replaced. So in the first 25 years, your primary cycle was where the manufacturer thought it would be replaced. Well, here we are now, almost 50 years into its life cycle from the 80s, and there's still no suitable replacement for the vacuum circuit breaker and for the power breaker, the low voltage power breaker. They keep talking about, graphene and all kinds of advanced materials and SCRs and solid state breakers and, buy us a big SCR, turn it on, turn it off. But they started talking about that when I first went to my first seminar in Pittsburgh. When I first got into this business in 1979, I went to Pittsburgh for an OEM conference meeting, and they were talking about these solid state breakers they were developing and how soon they were going to come. And here we are my whole lifetime later, and they're no closer to being able to interrupt the levels of power at the voltages they have to today, because those voltages and KA ratings continue to increase and escape them. So we really don't have a suitable replacement for the vacuum breaker today. So you're going to be stuck with it for the foreseeable future. So it's already 50 years old. I can see a 50 more, so 25 years to 100 years. So we've got to be able to keep this equipment in service 100 years. So the decisions you make today for your owners, for your customers, needs to be, how do we keep this equipment that was designed to operate 20 years in service for 100 years? And we talked about that in module 1. So a review of module 1, possibly rewatching the video if you weren't here, or give me a call. We can talk about it. We'll be posting some phone numbers and email addresses at the end. So the equipment goes into service, and we're going to pick 5 years as a basic maintenance cycle. We're going to talk a lot about maintenance cycles in the last hour, but for right here, I'm picking 5 years. After 5 years, it's cleaned, it's maintained, it's serviced, it goes back into service for another 5 years, another 5 years, another 5 years, for 100 years. In that period, there are some times where there are upgrades and life extension programs to include the insulation, increase its ability to interrupt current, new insulation, new current carrying components, rebuild, overhaul. Also, we can talk about things we can do to the controls to improve the relaying and control and the controls. Okay, so the key takeaways from that first module was, and like I said, go back and review the video if you didn't see it, or give us a call. We'll go through it with you. You cannot test in reliability of these systems. You can't come in here and expect decisions you made back here not to impact you. So if you weren't doing the testing, you weren't doing the inspections, you weren't doing the maintenance correctly, by the time you get to here, just simply testing it is not going to get you a reliable system. You have to do the work diligently, year by year, maintenance cycle by maintenance cycle, to build up the system and build it into a reliable system and maintain it as a reliable system. That reliability has to be earned. Okay, it has to be learned with regular inspections, testing, updates, and life extension strategies. So there's life extension strategies that will come in and help you extend the life of your switchgear and your operating systems. And if you look up here, when I said reliability has to be earned with regular inspections, I put inspections before testing for a very good reason. Inspections are far more important than testing, okay? Putting human eyes on it, seeing if it's dirty, seeing if it's clean, listening to it, paying attention to the condition of the equipment, looking at it, looking underneath the equipment to make sure a lot of the oil and grease hasn't leaked out of it, looking under the equipment to make sure there's not a pile of metal filings underneath it on the cubicle floor, looking at the relaying to make sure there's not a burnt spot on a PT or a CT, and there's not a big PD signature or acoustic signature. All these sorts of things that come in inspections. An inspection to me is an audio test where you listen for insulation breakdown. It's oil testing and transformers. It's cable testings with PD detection. It's all these sorts of things that are inspections. Some of it's online, some of it's offline, but it's all very important. The actual testing is where you actually apply a potential or a current and look for a particular result to test the system and make sure it's going to perform as required. Make sure you're doing the inspections, follow up with a good testing program, think about engineering updates for the equipment, think about a life extension strategy to continue to upgrade the equipment to modern insulation, to modern lubricants, and to modern electronics and modern instruments in your overcurrent protective devices. You must remain observant and diligent with plans and upkeep to earn reliability in the electrical system. You have to maintain an observant and diligent posture, and you can't go to sleep on it. You can't skip a session. You can't skip a process. You have to stay on top of it, or it will come back to haunt you. Then we went into acceptance testing. Acceptance testing is very important, because when you get the equipment, you want to make sure before it goes into service, or when it just goes into service, that it will survive the warranty. And you want to make sure that it's properly specified and it's installed correctly by good contractors used good industry accepted standards for terminations and splices, cabling, applying ring lugs, all the things that have to happen, suitable grounding, and suitable acceptance testing. It's important that there's a good inspection done and there's a good testing process done. We talked about who does that acceptance testing. Do you allow the manufacturer to do that acceptance testing? The manufacturers are pushing hard, especially in the data center world, to be a one-stop shop, meaning they want to sell you the gear, they want to come out and do the acceptance testing, then they want to maintain the gear. Having them do the acceptance testing is probably not a great idea, but they're usually willing to give you an extended warranty period if you will allow them to do that. Why do they do that? The reason they do that is so they have a time, maybe to correct problems, whatever, that they run onto in acceptance testing. And they feel like the acceptance testing will segue them into the maintenance program. So be careful having the original manufacturers. If you're going to do that, make sure you're on top of them and you have somebody on the program that can watch and witness what they're doing and make sure they're not essentially covering up any workmanship errors that they find. You want to know about those because you want to follow through with them. So make sure your maintenance team's in place. They're educated. Make sure that they are somewhat certified or qualified, and work hand in hand with your contractor to develop the relationship with both the user if you're a contractor and the contractor. You know what I mean. Make sure that you have a good relationship with your contractor if you're a user, and make sure you have a good contract with your user if you're a contractor. Now we start into unit 3, module 3 or unit 3 here basically is how does maintenance testing segue in or connect to acceptance testing. So you've done the acceptance testing. It's now some number of years later. and you've decided to come back and do some maintenance testing. What that interval is, we're going to get into it. There's several levers you can pull to impact this. There's lots of maintenance technology out there that's been developed in the last really 50 years. In module 1, we talked about life cycle 2 acceptance testing. Now we're going to get into the maintenance program. So conditions, accessing the conditions and setting up proper maintenance frequency is always a point that gets brought up everywhere I speak around the country. I always get these frequency questions. I was in Ohio last week at a major oil company's yearly electrical maintenance meeting, talking about frequency. That's really what they wanted to talk about. They're wanting to extend their maintenance frequency to 10 years. Okay. So they were wanting ideas from me and from my group of companies to give them ideas, the types of things they could do online that would give them a glimpse into the condition of the equipment to allow them to go to 10 years. Now, at first, you think, well, that's not a good idea. And I don't feel like it's a good idea, but there are probably some situations to where a longer cycle can be justified as long as the proper steps are taken. When I first got into this business, which was in the late 70s, we tested most everything every year. High current test, high potential test, all that sort of thing, Megger, ductor, the whole thing, controls, relays, induction disk relays, the modern solid state relays that were not digital at the time. So all that stuff was tested pretty much every year, and that was the standard in industry. Now, there was just as many places probably that never tested their equipment and they ran to fail. That's a philosophy that you have to balance, and we'll talk about that in future slides. But basically what happened is the testing went from 1 to 2 to 3 to 5 to 7 to 10 years. That's pretty much the way that the maintenance cycles adjusted. When I first got into the business, everybody was pretty much 1 year, particularly the Bell companies and heavy industry. Then they started skipping a year and doing some secondary checks and some, random checks of individual based on criticality, then to 3 years, then to 5, then to 7. Now some people are looking to go to 10. The problem with that is we've done advanced aging studies on lubricants for EPRI and for other people, and we don't really have a good feeling about parting times, interrupting times, and on overcurrent trip devices, breakers, circuit breakers, oil breakers, when you get beyond probably about 5 years. And that's what the data shows. The data pretty much shows that if you take a circuit breaker and you close the contacts, you apply 1,000 to 2,000 foot-pounds of force, and then you wait 5 years, and then you ask the breaker to respond with reaction time, parting time, speed, and velocity that it actually had minute 1, day 1, you're going to be disappointed. You typically see parting times in the 20, 30 millisecond range. They're going to go to over 100. So basically, you're not going to get reaction times and parting times that are going to enable the breaker to interrupt and maintain the radiuses that you have for your arc flash boundaries for your PPE and protective equipment, as well as you're going to damage equipment. So going beyond 5 years on circuit breakers and relaying is probably a mistake. Also doing circuit checks to make sure things work, fingering relays to make sure things operate correctly. So we're going to go into a little more on that. But right now there is a push in American industry to extend those rates, and they want to know what can we do with online testing that will afford us to do that. IR only goes so far. Okay, PD and testing for Corona only goes so far. What can we do? Oil testing is great. Okay, online testing for PD, online testing for breaker speeds and parting times. You only get that with certain trip devices when you open the breakers, and you don't open them often enough to get first trip times. We're going to talk about that further on as well. So typically, long-term maintenance is inspect the equipment. First, you determine the cycle, determine the frequency, the criticality of the equipment. The parking lot lights, you may not need to test that breaker every year. The primary coolant pump circuit at a nuclear plant, maybe you ought to test it pretty often. So there's some criticality that factors into all this. Then after you do the inspection, there's a clean, lube, and adjust cycle, which is very important. And I've seen just as much damage done by improperly cleaning, lubricating, and adjusting equipment as letting it set. So make sure you have qualified people. There are a lot of technicians that work with a clip jumper and a tweaker screwdriver, but they have no idea how to properly clean, lube, and adjust a low or medium voltage circuit breaker or a protective relay, like an induction disc relay. So be very careful who you allow in to do these clean, lube, and adjust cycles. Make sure you have qualified people. Make sure they just didn't drag some people out of their motor shop or their rewind shop or electrical contractors out there to do the work. Make sure they're qualified and they have experience on the type of equipment you have. Then after you've done the clean, lube, and adjust, there's a testing process by which do we do secondary, do we do primary testing? That depends on the equipment, the frequency, how hard it is to get the equipment there. When was it primary tested last? Did you have a primary test done on a low voltage breaker during acceptance testing? Now it's 3 to 5 years later. Is it suitable to go in and do just a secondary test and skip a cycle with the primary test? These are all things that you have to make that decision based on the time that you have, the contractors you have available, and the criticality of the equipment. Frequency concerns, how often should we come do this? Inactivity, how long has the equipment been inactive? How long are the breakers and relays been sitting there inactive? They've not been exercised, they've not been opened, they've not been closed. There's also run to fail versus condition-based maintenance that has to be considered. If this equipment is in very nice, clean, modern shape, it's very clean, it's in a pressurized room, it had acceptance testing 5 years ago, it all came through, every squawk was corrected, maybe you run a little longer, maybe you don't. These are concerns that you have to take up with your customer. I know on this call, on this webinar, there are a lot of users. I went through the list earlier today. There are a lot of petrochem, a lot of heavy industrial users. And this is very critical because I know you're being pushed to reduce the maintenance dollars, but bad things happen. So going forward with your mechanical and electrical inspection plan, make sure you have a clean, solid plan for lubrication. Make sure you realize who's going to be doing the lubricants, what you're going to use. There's all kinds of ideas, all kinds of studies. I can do an entire hour I can do an entire day just on lubricants. But let's just leave it at this. If you don't know what's in the circuit breaker or switchgear at this time, don't replace it with something that might be incompatible. So you have to know what's there, or you have to clean it all out and start from zero, something new. You cannot do that work easily in the field. It's very difficult to take the lubrication and properly lubricate a low voltage breaker or a medium voltage breaker in the field. So take all this into consideration. Sometimes you're better off leaving it alone than you are injecting a new lubricant into the situation if you don't know what's already there. And speed and parting times will give you an indication for this, and we're about to get there. So secondary versus primary, I think you have to do a primary test initially. At some point that has to have been done to prove out all the circuitry, to prove out the CTs, or all the plugs plugged up, or all the wires run the proper places. Can you inject a secondary test every cycle or two? Absolutely. But that's something you have to work out based on the criticality of the circuit. And your local NETA or Pearl guys or your local qualified industrial testing company can absolutely help you. Do a little testing to where you test a few circuits and see what happens. Get a little sample before you make a decision there. Okay, then another question I get asked a lot is, should we, we don't have a NETA testing company. We don't have a qualified, certified company, but we have good, solid manufacturers. The people left, started their own company. They used to work for ABB or GE or Westinghouse. We're we're familiar with them, they worked in our plant, but they don't have the accreditation. That's a situation that you have to follow for yourself. You have to decide as a company, are you going to require, need a certification or some sort of certification for the technicians, the people doing the work or not? That has to do with how you feel about your contractors and what has been their success. There's advantages to NETA. You get their safety standards, you get all of their database, you get all the third-party testing. They have a wide experience across the industry. And non-NETA affiliates, why and why not? The why is they may be close. They may be the guys that help build your plant. They may used to have been technicians for the manufacturer of the type of equipment you've got. Those are all good reasons. Why not? If you bring in people that's just going to bring in a bunch of electrical contractors or casual labor or fly all the manpower in from all over the country the night before the job, you're probably making a mistake. Okay, there are some large service companies in the United States that if you're in a place, they will fly in the crew the night before. The first time they see their test equipment is the day of the job. They don't know if the test leads are there. They don't know if the test leads work. Some of the equipment they're not familiar with, and they're going to have to learn all that on your project. So be very leery of people that are going to fly in subject matter experts or labor from all over the country and don't have a suitable staff close by. If they're NETA, that's another story. Those people work to a different level of standard. On older switchgear, it's basically, what is your frame of mind? You've got gear that's 30, 40, 50, 60 years old. You have to spend a little more time being diligent with the inspections, and you have to have money put into life extension programs if you're going to keep this older gear in service for the next 100 years. If you've got equipment that was put in the last 10 years, you've got a different class of equipment. The insulating material is different. The electronics and the wiring is different. Everything is different. Now, there are some advantages to the older equipment. There are some disadvantages to the newer equipment. The older equipment dealt with weight of copper and mass, where the new equipment typically works with speed and contact pressure to get the same ampacity through the breaker. So the modern breakers are not as heavy, and they're more subject to failure with thermal overload than the older breakers are. Other than that, the modern insulations are far better than the old insulations, so it's kind of a wash. The modern epoxies and non-organic insulations are way superior to the old paper, wood, and organic insulation that was in the older equipment. What tests should you do and how often should you do them? That's the big question. That's the question I get all the time. And that's something you really need a professional. You need a local contractor, a local NETA, a local Pearl, a local X, or a local manufacturer's representative that can propose a good balanced plan for you. You need a good balanced maintenance plan. Determining why to.
Do you have a question that came in, if I could?
Sure.
Yep. This participant says, I found a company having NETA accreditation does not necessarily mean that technicians know how to properly conduct the testing work or interpret the results. Do you have tips on how to vet these types of companies?
Yeah, well, there's no doubt. Okay, there's no doubt. You get a lot of NETA or any particular people that will come out onto projects that aren't prepared for the equipment you have. What you really want is you want a NETA level 3, NETA level 4 guy running your job. You want some of those types of people handling the test equipment, but you want some guys that are familiar with the switchgear, racking, switching, Kirk locks, racking mechanisms, lubrication, cleaning, and people that are familiar with the breakers. So the best balance is to come up with a NETA certified supervisor, a NETA certified level 3 guy in all the key positions, and then the people actually doing the work know about the equipment. That's hard to find because most of the NETA guys that know about the equipment, that know about switchgear and stuff, eventually work their way up into the 3 and 4 ranks. And when they do, they don't want to do that work anymore. So they relegate it to the helpers. So being from that world, I was one of the first NETA guys. I know the world pretty good. It's a very catch-22 situation. because as these guys improve in their licensing and their certifications, they are less likely to want to pick up a wrench and actually do the work. And they then bring on helpers that actually do the breaker repair, breaker testing, moving the breakers around, the cleaning, that sort of thing. So the people that actually put their hands on your switchgear and do the switching and stuff have to be qualified. It's a hard situation. And, you know, the way you get around that is, as a user, is you ask these questions. Give me a bio, a one-page bio of the 14 guys you're bringing out here. Give me a little quick org chart that shows who's going to do what and what their bios are. And if all the strength is the top 3 guys and they're just going to have a clipboard in their hand, you got a problem. I hope that answers your question.
Good deal, Finley. Thank you. One more, and then I'll let you move on. Dave asks, what about NICET or NICET trained techs?
Great question. And I'm a firm believer in the NICET program. It's actually tougher than some of the others at certain levels. But just because you have a NICET certification doesn't mean you have any power, real power or real energy or switching experience. The advantage to the NITA guys simply as they deal with switchgear every day. You can be a NICET qualified technician and you work on TVs, okay? Or you can be a NICET qualified technician and you can be the greatest guy in the country. So you have to be careful there what you're getting. I love the NICET qualifications. If a technician is smart enough to get through NICET certification, he is probably smart enough not to put his hands where he shouldn't and not work on equipment he knows he shouldn't work on. And that's a real advantage.
All right. Thank you, Finley. Just to let everybody know too, the chat is available for any other questions, but you can also use the Q&A box. Thanks. Go on, Finley.
Yep. Okay. We're 35 minutes into an hour, so I got to get moving here. Basically what this is telling is the bottom, these are years. So that's 2 years, 3 years, 4 years, 5 years, 6 years. At about 1.5 years is where the total dollars used spent to maintain the equipment. If you continually maintain and service the equipment every about 1.5 years, you will actually spend the fewest dollars on failures. You know, you can spend $150,000 on a big weekend shutdown, okay? 3,000 to 150,000, and anywhere in between. That 150,000 is inconsequential. If you lose a section of gear, that section of gear smokes up the 2 adjoining sections, and at the same time shuts you down for 3 or 4 days while you're acquiring the gear, bringing it in, putting it back together, and getting the plant back up. So there is a situation here to where there is a diminishing return. When you get out to about 3 years, 4 years, you know, in through here, it really financially becomes a question of hit or miss and what do you want to do. When should you perform maintenance? Should you break it up and do it in sections and do a little bit every year? If it actually includes an inspection, that's probably a pretty smart thing. Going beyond 5 years, I can't recommend. Anything short of 5 years, I think you are doing yourself a favor. Beyond 5 years. At 5 years, lubrication issues begin to pop up, and 80 or 90% of the problems you're going to have in a shutdown are going to be insulation and lubrication. You know, key factors or indications on frequency is, have you had any near failures? Have you had any near misses? Have you had any instances where maybe the breaker didn't operate correctly, but it was never called upon to do so? So essentially you don't have a failure. So when you go out and test a big bunch of breakers at a petrochem plant, we typically see 12 to 15% of the breakers that would not have successfully interrupted a fault or protected a piece of equipment or a person. 12 to 15%, depending upon the manufacturer. That's at a less than 5 year maintenance interval. You go beyond 5 years, say to 7, and we start to see 20, 22, 23% of the breakers running at a speed and velocity or having an issue with lubrication or a mechanical issue or a timing or calibration issue that might have caused a failure. Then the breaker would not have performed if it was asked to do so properly. First trip times are your best indicator of that. Now we're just talking about circuit breakers, not talking about relaying as much, but the two systems work and have to be maintained in concert. But when you're dealing with circuit breakers, if you can gather first trip data and you can look at your first trip data and it's maintaining to be consistent and to the point that it starts to fall off, that's the point you need to address maintenance interval and lubrication or both. You know, oil analysis, insulation analysis is a big part of your overall maintenance plan. Protected device calibration. Do you still have some induction disc or thermal relays? Have you gone completely to digital relays, gotten rid of all of the older electronic relays that were non-discrete? You know, no longer analog, no longer induction disc. You know, there's things you can do to look forward. You know, the new modern relaying, if it goes in and set up properly and performs right the first 6 months, it's probably going to live a long time. The older analog stuff drifted and died over time, so it aged and died. Induction disc is some of the most reliable equipment ever built, some of the most repeatable equipment ever built, but you've got contamination issues, you've got all kinds of issues with hot versus cold and condensate. You've got all kinds of indicate all kinds of problems with finding parts and pieces and people that really understand it today. I hope I'm not moving too fast. I'm kind of on a schedule here, so I'm trying not to get yelled at by going too slow, and I'm trying not to go so fast that we can't have a few questions at the end. You know, standards are a big deal. You know, ANSI, all the ANSI standards, NETA has all these ANSI standards, IEEE standards, NFPA, NEMA, UL, all the standards are important. You know, these standards are put in place by people that know what they're doing. I'm no longer involved in that. I used to be years ago. Some of our people are. There's people on these committees that know what they're doing. They make sure that there's also people on these committees that are overburdening these standards. So there's some of both. But basically, it's a real good idea to stay involved with these standards and check what they're actually say versus what your contractor is actually doing and do a comparison check there. These standards are also global standards, so we should get input from all around the world. The NETA maintenance standard is a great reference. You know, the Doble results from the Doble company years ago was a great way to look at oil testing and breaker testing. The MTS standard is a great way to get, I'm not sure about this, I want to check myself. It's a good idea to go compare to the maintenance standard, look at what should have been done, look at what results you should expect to get from the MTS. You don't have to be a NETA guy to conform to NETA standards. It would be really smart to at least browse through these standards before a shutdown, after a shutdown, after you get your test report. When the contractor comes in and says, we need to do these 10 things, it would be a good idea to review the test results and consult these standards. Just a little clue I'm giving you there. There's many considerations. You know, there's maintenance philosophy. You know, you got to focus on the big picture. You've got to clearly design a scope for each section. You can't. We used to do a shutdown at Texas Instruments in Dallas where we'd bring in 150 people, 10 or 12 generators, 10 or 12 high current test sets, 10 Doble sets, and we'd test the entire site in a weekend. You don't see much of that anymore. But you know, your maintenance philosophy is, here's the big picture. We want to get all this equipment done. Here's the number of years we have to do it in, break it up in adequate segments, clearly define the individual scopes, agree on a strategy, agree on a contractor, be sure to use active listening. Listen to your contractor, listen to the users, interview people that are actually operating the equipment, and seek guidance from subject matter experts on things like circuit breakers, relaying, cable testing, PD testing. Find the people in the industry that really know. Choose your contractor wisely. Whether it's NETA or non-NETA, just choose it wisely. Be in the loop. Even if you're using your own people, it makes a lot of sense to bring in a qualified level 3, level 4 guy just to look at your program, just to audit what you're doing. So what if you use your own people? Bring in a qualified guy to audit what you're doing to make sure you're not making some very simple mistakes in safety, in maintenance, okay, and in operations. always consider the time available. There are new techniques today for online testing that will get you a big piece of the information before you have to shut down. And that's really important to get as much packed into a short time window as you might have. Be prepared for the dreaded red sticker, okay? If you test it, you're going to find things that fail. If you find things that fail Sunday night, you're not going to be able to re-energize it. Be prepared for that. Don't go into something thinking we're going to test everything, calibrate everything, and Sunday night at 7 o'clock, we're going to turn the plant back on. We're going to turn the process back on. We're going to turn the machine back on. What happens if that relay, that CT, that PT, that cable, that circuit breaker fails test? Okay, and you cannot re-energize that circuit. Where is my spare breaker? Where is my spare relay? Where am I going to get these PTs or CTs? Where am I going to get some insulating material to re-insulate this ping that's eaten up with partial discharge? Do I have a terminating kit? Do I have a splice kit? Do I have this stuff? Be prepared for the dreaded red sticker. And everybody that's been in this business a while has been in that situation to where you hate to go tell the customer, I've just found a cable that we're not going to be able to re-energize. And then typically the customer or the owner is going to go through a complete ballistic 30-second nonsensical stance to where you're going to have to just wait, let them cool down. Then, cooler heads will prevail. And if there's not a workaround and they want to re-energize it, make sure you get them to sign off in writing that you're turning a circuit back on that you're recommending they not do, because you will see that. They will promise you they will replace it, and you'll come back in 5 years and that cable will still be in service and the results will be way worse. It'll be way hot and they will have jumpered all kinds of circuits around it. So be prepared for the red sticker. Always take equipment criticality and device significance into consideration. Is it the main substation feeding your entire plant? Is it a breaker feeding a small section of your plant that has nothing critical in it? If they're the same breakers, maybe you need to swap them. We ran into a power plant in Central Texas a few years ago. They were started having breaker failures at about 3,000 operations. Yet they had 8 or 10 out of 80 breakers with 3,000 or 4,000 operations on it, and the rest of their breakers had about 100. Maybe during maintenance, someone should have suggested they take these 3,000 operation breakers and put them into non-critical circuits and move some of these breakers with only 100, 200 operations on them onto these repetitive duty critical circuits. That's the sort of simple things that'll make a difference. Current condition of the equipment, is it clean? Is it dry? Is there water infiltration, bugs, spider webs, snakes, mice, all the things that kill the switchgear? Do you see any of that? Make sure you're using proper lube. Make sure you're cleaning the material before you relube it. Don't mix incompatible lubricants. Never use a spray can with a light lube and anything mechanical. Be very careful washing out all the grease and getting some light lube in its place, because in a few months you're going to have a failure. Always consider the maintenance history, the operational history. Have they had outages? Have they had problems? And go with industry experience. Talk to the NETA guys, talk to the Pearl guys, talk to the manufacturers, talk to the people that actually have the experience. Listen to what they have to say, and decide which way you want to go with your equipment. Basically, we've said, it's got to be performed in some routine. You're risking failure if you don't. I don't think maintenance intervals should exceed 5 years generally. There are always changes to limits. Some should be obviously faster. There are probably some arguments for a little longer, mostly due to the limits on lubrication. Life might be shortened further if adverse operating conditions exist: humidity, temperature, repetitive duty, poorly applied. Salt water is a killer. Be careful. Was there a flood? Was there a hurricane? Was there a big thunderstorm that passed through the night before the failure occurred? Industry standards should be followed in some way, if not just reviewed. If you choose to go your own way, that's fine. Review the NETA standards, review the ANSI standards. At least review them so you're knowledgeable and you understand what's out there. I got to check my time. Okay, we're doing good. Lubricant, the life effects of lubricants is very important. Age, contaminants, temperature, and incompatible lubricants. That's the four big killers. So be careful spraying anything, replacing anything, allowing a contractor to bring any lubricant and inject it into your mechanical systems if they don't know what they're doing and you're not sure it's correct. There are industry standards in the MTS. There are charts and graphs and all kinds of data. Very smart people put this together, showing conditions for 2, 3, 4, 5 years of between maintenance cycles. Take a look at this, at least review it, and have the input in your mind before you make your own decision. Let's talk about clearing time. I got just about enough time to do this, and I wanted to get to this because it's very important. Is a lot of people don't understand what breaker timing is all about. In breaker timing, when you actually send a signal for the breaker to trip, there's a certain amount of non-intentional time delay that goes into before the trip coil is energized. Then there's actually a little bit of time between the trip coil being energized and the contacts beginning to move. So this is particular here is kind of inherent to the system. Then in here, there's some mechanical delay due to lubrication and other factors. So basically, this is parting time. So from here to here gives you the parting time. Most timers that you use today to determine the mechanical health of your circuit breaker measure parting time. Beyond that, there is parting time, there's velocity and speed, there's contact, bounce, all sorts of things that come into play. But basically, if your parting time is good, we've learned that it's going to run close to speed and velocity. Bounce is another story. So most people just test for parting time. That does give you a good, valid test and give you a real indication of the lubricant and your maintenance interval. So if those parting times are going up, which they will start doing after about 5 years, you need to know that. And at that point, you need to either change your lubricant, increase your lubricant, or decrease your maintenance interval. The parting time, the operating time, this is the clearing time. All the way across is the clearing time, because that's the time it takes to send a signal, please open, we've got a problem, for the trip latch to drop, or for the solenoid to begin to be energized, then for the contacts to part. That's parting time. Then the contacts have to move across an arc. It has to bow the arc, and the arc has to be broken up in the arc chamber and extinguished to interrupt the circuit. And that total amount of clearing time is what's required for your arc flash study to be valid. So you have an arc flash boundary that's based on optimal conditions and things running at proper speed and velocity. If they don't, as time extends, this arc flash boundary extends as well. So if a 30 or 40 millisecond breaker is pushed out to 100, like it would be with a long setting inactive for many years, now you've doubled the arc flash boundary. And I'm pretty sure that the standards now say you will, not that you might, verify that, and you might comply, and you have to comply with that. So just be careful what your company's policies are, what your personal policies are, and where you can, you need to get these breaker timing information, breaker partings times, use that to evaluate your interval on your machinery and your protective devices and your interval on your lubrication. Are you using the right lube? Now, you've heard this term magnetic and air blast. What that is, I just want to go over, is there's sometimes a magnetic coil or a puffer tube assembly that helps push the arc up in the arc quencher and help extinguish the arc. So with higher currents and higher voltages with air breaker, that was required. With vacuum breakers, we get next crossing 0. Circuit breakers arcing time defines the duration of the arc flash. Total clearing times, very important. It's not just parting time. It's not the time you get from a simple timer. Realize that. It's a bigger number than that. The total clearing time value used in the instant energy calculations are very important to ensure that your PPE is correct. How can it be proven that the protective device will perform as advertised? Timing is really the best tool you've got to do that. So make sure you're either looking at first trip timing, or you're looking at overall clearing time, or you're running a transducer and getting the whole package. But make sure you're using some timing information to determine if your maintenance interval is right and if your lube is right. If you don't get a good metric there, you don't really know. Until recently, it was very difficult. There are modern timers today that are easy to connect. Doesn't take a real high-end person to get credible data. Think about timing results. Think about adding that into your breaker maintenance program, your switchgear maintenance program. Trend that to see if your lube is right, to see if your interval is right. If those times go up, it's a dead indicator. You either have a lubrication problem, an environmental problem, or your frequency of maintenance is too low. Excuse me, too long. Boy, I tell you, we're getting here. Circuit breakers are only designed to have a 20-year life. Now that they got steel bearings in them today, and they're lubed for 20 years. So make sure that beyond that 20-year period, you're doing proper maintenance. Many are now approaching 40 years. They've been in service reliable, but a lot of them have never been called upon to interrupt a fault. So as a maintenance professional, you need to make sure your relays, your protective relays, your trip circuits, your CTs, your PTs, that the trip circuit between them and the breaker will operate. Finger the relays, operate the breakers offline, and make sure the system works. The PTs and push current through the system, make sure the relays operate, make sure the trip circuit is intact, finger the relays, make sure the breaker trips, make sure it sounds right, runs right, acts right, and smells right. Pretty easy, huh? Keys to life extension, industry recognized maintenance strategy. So keep it clean, keep it reliable, keep it in good operating condition, determine its criticality and how much remaining life you need out of the equipment. When are you going to be able to replace it? Are you ever going to be able to replace it? Verify the trip times occasionally to make sure mechanically it's okay. And maintenance intervals not exceeding 5 years, certainly not 7 or 10 generally for inspections and cleaning. Okay, so be careful there. That's my recommendations. I've only been doing this 45 years. I guess I could be wrong, but that's what I recommend. Okay, here's some phone numbers. I'm going to leave this up on the screen. If we've got any questions, if you'll send them over to Justin, I'll take any questions you got. We got 5 or 10 minutes here.
Yeah, thanks, Finley. I do have a comment followed by a question, and they say, this one says, we do not have the ability or time to perform primary injection testing on most of our low voltage breakers. Can you give more insight on how often breakers should be sent out for this type of testing? Also, we do secondary injection testing at a maximum of every 5 years.
That's pretty common. We're seeing more of that. You know, primary injection is slow. Now, is it slow compared to a failure? No. If you have good primary test results from your acceptance testing, that goes a long ways. Okay, that means at one point the CTs worked, the trip circuit worked, the wiring was correct, the system worked at one point in time. When you do a secondary injection test, you're just testing a small piece of the program, or you're not testing the power supply, and that's where the majority of the transient failures take place, and you're not testing that part of the trip device. You're not testing the CTs, PTs, and the control wiring. So if you could do a secondary injection test every 5 years, and then you can do a primary injection test on the next cycle, I would feel pretty good about it. This, again, I'm talking about a piece of equipment that's clean, it's modern, it's well looked after, not in a dirty industrial environment that has a lot of airborne contaminants or salt water. Then you've got to be every year or two doing diligent maintenance, or if it's on an arc furnace breaker or something that's being used repetitively, because breakers are designed for 1,000 operations between major maintenance. Okay, 1,000 operations between major maintenance. Major maintenance means the breaker's torn completely apart in every piece. Okay, so they're not designed like a contactor or a switch for tens of thousands of operations. So as long as you've got one good, credible primary injection test in the not too distant future, I wouldn't hesitate to secondary and test, but I would make sure certainly your critical breakers get out for primary injection every 5 years.
Great. Mose has some good comments in our chat. He also asked a question, though, what is a best practice for first trip testing low voltage circuit breakers?
There's several ways to go about it. There's 3 or 4 technologies to do it. Can't really get into it here. There is my email address, finley@groupcbs.com. If you'll send me an email and ask me that question, I'll call you and we'll talk about it in detail. There are 3 credible systems out there for gathering that data right now. They do require, one of them requires a lot of pre-wire work. The other 2 are pretty non-intrusive. So if you'll give me an email and let me know about your question, I'll call you and we can talk about it offline. Hope that's satisfactory.
All right, one more here. You may have addressed this, but which do you suggest? Conducting a primary injection test or a secondary injection test for an existing circuit breaker?
There again, do you have the results of a credible primary test in the last 5 years? If you don't, you have to have a baseline, and the baseline is a primary injection test. Okay, so you have to have a baseline. You have to know the entire trip system will work, or it did work at one time. We found electronic trip devices, when you take them apart, they didn't go through the soldering machine or just jabbed onto the board. On the back, there's no solder. So basically, you have to make sure the system worked credibly in the not too distant future. If you do, and you have that from a credible resource, then a secondary test every so often is acceptable.
All right. Is there a time or number of operations equivalent for breaker teardown for air circuit breakers?
Well, there again, you're talking about air breakers, you're talking about low voltage breakers. Low voltage breakers are not repetitive duty devices. 1,000 operations is a ton of operations on a low voltage or a medium voltage circuit breaker. There again, low voltage breakers don't have counters on them, so you don't know how many operations they've had. My recommendation is time kills all, operation kills all. So, if they've had a lot of operations on them, they're in a repetitive duty, they're starting a motor, they're starting a pump, they're the primary disconnect for a process you disconnect every day, then they need to come apart fairly often. About 1,000 operations is all you can count on from a low voltage breaker or a medium voltage breaker before you're going to develop. At about 3,000 operations, medium voltage breakers start to fall apart.
Well, that is the length of our questions so far. If anyone else, feel free to shoot it over here. If we don't get to your question, we will email answers to you. Just send those to me. I do have another one just came in. How does upgrading a low voltage breaker trip unit benefit my arc flash study?
How does what?
How does upgrading a low voltage breaker trip unit benefit my arc flash study?
Well, it doesn't unless you are upgrading it to a more reliable or you're adding features that will cut down the incident energy level that'll pass through the breaker. So an induction disk relay that was built in the 60s will do exactly what the most modern electronic trip device today will do. Operate a breaker against an inverse time characteristic curve at so many multiples of current, it will trip in so many seconds. Okay, both trip devices do the same. The subject of reliability now is another story. The modern trip systems are far more reliable than the old induction disk systems and the old dashpot and oil dashpot systems and the analog trip devices. So if you put in a modern trip device, it might have functionality that will decrease the let through current or make it operate faster than a fault. But you need to do a power study and you need to consult a quality engineer to come up with those settings for you and to determine which function you need to add to reduce arc flash let through. It's not as simple as I'm going to put a new trip device on. It's adding functionality and adding the ability for it to react faster or to sense and work throughout the system in a better way. You need an engineering study from a power quality engineer to make those decisions, and probably some coordination work.
All right, Colin asks, is there a time alternative to the 1,000 operations? We have a 30-year-old low voltage air circuit. We have 30-year-old low voltage air circuit breakers that almost never operate. What is the interval for teardown?
That all goes back to lube, okay? If you've got a 30-year-old breaker that's got less than 1,000 operations on it and it's never been torn down and you've never had it relubricated, every 5 to 10 10 years that needed to happen. So chances are you have mixed lubrications of different generations that are crudding up. I can promise you you've got a problem, especially if it's a main breaker or on a critical circuit. I would be very cautious with a 30-year-old breaker that's never had any major maintenance.
I want to point out the additional Group CBS resources here. We have a YouTube video library, our groupcbs.com. We want to be your everything go-to needed now supplier for everything electrical. So parts, circuit breakers, service needs, test kits from our vacuum interrupters branch and division. So, feel free to contact us. Finley, do you have anything else to add, sir?
No, glad to talk to everybody. Hope to see everybody back in a couple of months for our next segment. What's the next segment's title there, Justin?
The next segment, we are focused on life extension and making it to the goal line. So a presentation on life extension and hybrid replacement of key components to allow equipment to make it to the new expectations on 100 years. All right, thank you all. Hey, this will be on our Group CBS YouTube channel, as well as the slides will be available to participants. If you need that certificate of attendance, shoot me an email, and we thank you for joining us today.